I hope you understand how a quadcopter work in basics. So now I will tell the what the plan is with this course. So first, the first 2 to 3 classes will be at beginner levels, where we will talk about how to build a flight controller using STM32 F411. After that, we'll see how to upload firmware, like the you are seeing the currently you are seeing this firmware, how to upload it, how to configure it, the basic things. After that, we will see how to connect your transmitter receiver to it. Then we will do PID tuning, modes, different modes in a drone. Then we will use Fusion 360 to design a frame for your quad in CAD. And after that, the when the beginner session is over, we will go into the much more detail. Like I can show you if I have the code. Yeah, I have the code. So this is basically the flight controller source code, which you can get from the iNav GitHub. It we will do it later, and we'll see how this code works, how the sensor works, how we can made our own firmware, build our own firmware using iNav. Anyone has any question till now?
No, sir, not yet.
Anyone else? You can write. I think chat. I have any chat. You can also write in the chat if you don't want to open your mic. Any question, any simple, anything. You can ask anything, any as small as you can go. Let's, so yeah, budget depends. This course is not mainly for like I can just tell you to go buy this and that. Well, that's I don't think drone is something I can just tell you to go buy the motors and things like that. So it's mostly for learning than to make your own. If you want to make it, the things I'm using is the motor I'm using is 300 per motor, 300 per ESC. The STM32 you can get for 300, and the gyro you can get for 3 to 400 if you just want a basic drone. Other than that, if you want barometer, magnetometer, GPS, you can add on it later. And if you don't have 3D printer, you can just go buy a F450 type frame. You can easily find them. So let's start with the flight control, what we are using and why we are using it. The flight control we are using is STM32 F411. It's the cheapest flight microcontroller which supports iNav and Betaflight. While we are in this topic, let me also explain. We basically have three firmwares, open source firmware for drone. The first one is Betaflight, which is basically for racers and simple quads. Then we have iNav, which basically have more navigation features like GPS, mapping, um, optical flow, and TOF, time of flight sensors, things like that. The third one is Pilot, which is basically an advanced software. You use this when you want to make a fully autonomous drone, plane, anything. But STM32F411 does not support autopilot. You will need at least STM32F405 if you want to run autopilot. We will be focusing on iNav. For I have made drone on iNav, so I can tell about iNav the most. This is the iNav. We are again diverting from the path. Let's go back. So the main microcontroller we are using is STM32F411. I think I can also show you. Let me see if I can. Yeah, I think you can see the camera also. Yeah, this is the STM32F411. Currently I have. The video working or not?
It's did start, but I think it's frozen right now.
Yeah, I think it's froze. Let me see. Yeah, now it's working. Using OPS is not a good idea, I think. Let's let us drop it for now. See later. So yeah, we are using STM32F411, and the gyro we are using is MPU 6050. It is not recommended to use MPU 6050 because it works on I2C. I prefer you if you are gonna build a drone of your own, use MPU 6500, which is a SPI based MCU. But I don't have that right out, so I will using MPU 6050 for this course.
So, what exactly is SPI?
It's a communication protocol. We will talk about it when we go into the source code and the advanced stuff.
Okay.
So basically, if you wanna, in two words, if I have to say, I2C and SPI and UART are serial communication, and the main difference between SPI and I2C is its speed. So when you're using a IMU, you want the faster speed. So it is not recommended to use I2C because it's slower than SPI. So that's the main reason we use SPI communication when using something where speed is necessary. Now that you basically need a microcontroller and a IMU to build your drone in a simple drone without any advanced feature. Simple drone, you can just use these two components. Now the next thing is what software to use. Like I'm using iNav, so we will use iNav. So how to get iNav configurator? You can just go to iNav configurator, go to releases. In releases, you can just go scroll down, assets, and download which the system you have. Whether you have Windows, Mac, Linux, you can download from here. And the last thing we are going to use is our CAD software. So here I have Fusion 360. We will be designing our drone frame in Fusion 360. You can get it for free for personal use with limited features. Yeah.
Sir, is it feasible to make a frame for our own project every single time, or is it feasible to buy a pre-made one?
If you have a 3D printer, then it's best to design your own and print it. But if you don't have, you can just buy you can buy a F450 drone frame. I think you can get it quite easily, like this type of frame.
Mm-hmm.
If you don't have a 3D printer, you can just buy. You can purchase it. It's showing more, but it's pretty cheap. It's not that expensive.
Okay, okay.
You also need to consider that the frame I just showed you is for 10-inch propellers. The one I made is 6-inch. You can go to whichever you like: 5-inch, 3-inch, 6-inch, 7-inch, 8-inch, 10-inch, 12, as per your needs. So these are things we are gonna use. So we cover our microcontroller, the IMU we are gonna use, the firmware and software we are gonna use, the 3D modeling software we're gonna use, and the last thing is RC link. If you have a remote control, you can use that. If you want to see how to make a transmitter and receiver using NRF24L01, let me know. Uh, Let me ask the people. Guys, you want to see how to make a transmitter for your drone using NRF24L01? You can just raise your hand or you can speak. Uh, Jayavardhan, let's.
Yes, sir.
You worked with NRF24L01 before, or totally new?
Yeah, yeah, I'm totally new, but I'd like to learn about it.
Totally new. I will see what I can do about the transmitter receiver thing.
Mm. Okay, okay.
I think the other course with the robotic arm is also using NRF24L01. I will see if he is doing advanced thing or not. If I am gonna build it, then I'm going into deep in the course, like how to use it, how to program different buttons, different function with screen, OLED screen, and things like that. It's gonna be a lengthy thing, not simple. So these are the things we're gonna use basically, and the course is uh, gonna work like first we will see how to make a flight controller, how to make the connection, what to connect where, and how not to mess up your flight controller, because if you connect wrong, you will burn your microcontroller. So we will keep an eye on that. So the next video will be connecting the FC with its IMU, flashing the pre-made firmware into it, and basically setting it up, like calibration and things like that. Simple thing. After that, we're gonna in the next class. After that class, we're gonna see how to connect your RC link, calibrate it, check its function, check the modes, and check the motors if the motors are working or not, and in what orientation the motor should be, and things like that. After that, we will do PID tuning. In the PID tuning session, we will be doing live PID tuning with the drone not flying, but I'm working on it. I make a jig where we can put the drone and it will hover, and we will see how P, I, and D values differ with each other in live. I hope you will find it interesting. And after that, we will design. I will give you a what can I say? A blueprint of a drone, a 5-inch drone specifically, and we will build it in live session. And if you want, you can download Fusion 360 and build it with me. I'll be teaching basic CAD skills, what is what in Fusion 360, because that's the software I use and I only know how to use Fusion 360. So that's what we are going to use. And after that, when we are done with the CAD thing, we will go into the advanced course, you can say, where we will go in deep into the source code and see how to configure it. I think I have, if I can show you. Uh, Open. Uh, Sure, I think I have it. Let me see. I don't know where I put it. I have a code which I am using currently using in my drone, but I don't know where I put it. I can't seem to find it. Well, we will see later. So this is basically the iNav source code. You can, if you want to download the iNav source code, you can just go to iNav iNav releases and in the assets you can find source code here, from which you can make your own target if you say so. So this is basically how it's all gonna work. And this is my first time doing something like this, so if I'm not that good, please ignore it. This is my first time teaching someone. So yeah, this is how it's gonna work. If you have any question, you can ask now. Anyone, any question, any doubt, anything you wanna say, wanna know? You can also write. If you don't wanna talk, you can just write in the chat and I will answer it. Any specific screwdriver set? I don't know how to answer that. Why would you ask about a screwdriver set in drone making? I can't comprehend that.
I think he means about the assembling part.
Yeah, screwdriver set. I think you can use any screwdriver. It's not that you need a specific things. If you're buying a drone kit, you may need to know if it's using Phillips flat or Allen keys. So yeah, that's a different thing.
And I think
But
it mainly depends on the parts that you're using.
yeah, the part you're getting is dependent on what you get. Will you be able to make a drone with US with a- If you want to make your own drone with me, yes, you can. I can share what part I'm using, how I made it, everything I can share with you. And let me show you this also. If you are not gonna build your flight controller from source like I did, you can just go to this and you can download use these pre-made what can I say files with your flight controller. You just made connections like yeah, here's all the connection and you can just follow it, or I will also show how to do these connection in the next video, which is going to be about flight controller. But yeah, if you are not going to build it from the source code, you can just go to this page and just make it. It's pretty simple. If you don't want to get into the coding and things, you can just download this and upload it into your board and it will work. We will be covering it in the next video, so don't worry about it. We will go one step at a time. This video is just for getting an overview what we are going to do and how it's going to work. Anything else? And Jayavardhan, your mic is on.
Sorry, sorry.
Anyone, anything, any question? You can ask any question, any simple, basic, anything. You can ask anything you wanna know about drone and its components. Also, if you don't want to use STM32 and go into something much more advanced, then you can also use TNC microcontrollers and use, I think it was,
Sir, does the STM32F support camera connections?
STM.
STM32F, the one that you told us about,
Hmm.
does it support camera connections?
For camera connection, you will be needing a chip, which is you are asking about the OSD thing, the on-screen display and thing like that.
No, I don't want it to be my remote control to have a display, but instead I was thinking about a FPV kind of drone because I have maybe two or three cameras lying around which I can repurpose.
Uh, you can, but for that you will need a chip. I think it was in this. If you have a FPV camera, you can connect it directly. I think if you want an on-screen display, that's a different story. If you want an on-screen display, let me show you. I think it's best if I show you then to talk about it. That's
Hmm.
nice.
Sure.
I will go into it, connect it, and go into OSD. It's keep on loading. Yeah, you are talking about thing like that.
Yes, sir, something like this.
Yeah. So if you want to use this, it can work in this, but for this you need a special IC, which is this one, Max 7456 OSD module, which I can't find in India. I don't know why, but I can't find it in India. If you can find this chip, it will work with your camera.
Oh, okay. So there are no alternatives as such.
No, the thing is the iNav, the software we're using, support this chip and some other chip, but that's not what can I say? Those are SMD chips. We can't work with those. The breakout board type of chip is only this chip.
Acha, okay, 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 all right.
Uh, if you're talking about FPV drones, I think you know what how a FPV drone work, the camera, the VTX, and things like this.
Some parts, yes, but I wouldn't say I understand it completely because I'm also a beginner. So,
Let me give you a quick overview on FPV.
sure,
There
sir.
are there are two types of FPV. Where the first one is you just take a camera, connect it to a video transmitter where there is analog or digital, is up to you, and it just transmit videos without these things. If you can see, you can there the battery voltage, your GPS coordinates and things like this. It won't show these, just the video, and you just receive the video in a goggle or in your phone or things like that. The second type is with an OSD. OSD stand for on-screen display, in which where you can see your mode, your battery voltage, how much time, how far away you are from the your landing point, and things like that. If you want to use OSD, then you will need this chip. If you want to use just the camera, nothing as like no OSD, you can just basically connect a camera to a VTX and it will work. You don't need anything else.
Acha. So if say I use the OSD, then I won't see what the camera is seeing at the time while I'm flying, right? It will only be visible to me after I like take out the videograph data from after I land the drone, something like that. No,
I don't quite understand what you said.
like the first type of drone that you just told us about,
Yes.
it had the signal processing strength, and it could display the video in live time on some kind of goggles or some kind of screen on the remote control,
Yeah.
right? But while I'm using OSD, I won't be able to see what the camera is seeing in live time, right?
No, you will see in OSD mode, you will see the same thing, just with the extra things like your battery voltage and things like that, which is crucial in sometimes.
Acha.
It will be
Okay, okay.
same, just extra information.
All right, all right, I got it.
Uh, I think we got some questions. How much duration will take to make a drone? Depends what type of drone you're making. If you're making simple drone, then it won't take half a day, I will say. But if you are a absolute beginner, then that's a different story. How many times in a week are we planning to meet, and will we be able to get a recording in case we can't join live? Yeah, I will be sharing YouTube link for the uploaded videos in the course. Another question: since I am at a foundation level, it's comprehensive for me to take the course. I will take this comprehensive. What do you mean comprehensive for me to take this course simultaneously? You can just take it for fun. You don't need to stress over it. It's you can just take it for just fun. We're chatting about drones and things like that. You don't need to take it too seriously. If I have to say so. Any other question? Talk to us about yourself. I don't have much to talk about myself. I'm just a hobbyist doing its own thing. Like, how did you start drone making? I just don't make drone. I make everything. I started with a plane, then bots, then here I am with a drone. Wait a second, I have a call. Yeah, I got a call. Uh, what we are talking about? Yeah, about myself. You can also talk about yourself if someone wants to. It's just me talking. It's not that good. You can also open your mic and talk about anything you want. I'm going to use
I think it will be mostly radio controls. Bluetooth is not very feasible.
Bluetooth. Yeah, Bluetooth is not that feasible. The only purpose you can find in this is to use it with like this. Yeah, you can connect to iNav using Bluetooth for programming it. That's all. Other than that, is there's no use for Bluetooth in iNav.
Hmm.
We will be mostly talking about high level transmission links. So Bluetooth and Wi-Fi is not feasible there. The one I am using is currently ELRS modules. That's I have. If you have Fly Sky and something like that, you can work with that also. Anything you wanna say or you wanna add in this, that like you wanna learn something that I missed or something like that, you can just type or you can ask, open your mic, you can just talk to me. I think I can. close this now. Any other question, guys?
No, sir, not really.
And no need to call me, sir. I'm also a student.
Yeah, but you're still our senior, right?
No problem. I hope it's recording. Yeah, it's recording. I don't know why the video is not.
Yeah, it's working.
L- Let's leave it that. I will figure it out later. What kind of project you have made till now? I'll say the biggest project of mine right now is the drone, and other than that is the ELRS modules which I have made myself. If I can show you these, if my camera works. Mm, Let me just. I think it will work in this mode. Nope, just don't want to work. Let me just show you. Mm, If you can see this, yeah, light. Yeah. So this is basically the ELRS module which I have made, and that I don't my laptop. Yeah, this is the old remote I have made for my other projects, and this is the ELRS module which I have made for controlling the drone. This is the transmitter module, and this one is the receiver module. So yeah, I made these kind of things, and other projects are somewhere I don't know where they are. This is extruded.
That looks amazing. I want to know what does it help with? Does it help with the better latency or longer range of transmission?
Yeah, its range is pretty high. The recorded range is 100 kilometer for this module.
Oh wow, that's too much.
Yeah,
You could cross a city.
yeah, uh, and the the ELRS thing is open source, so you can build your own if you want to. Let me just show.
Right, but the transmitting chipsets, I think they'll be costlier than the normal ones, right?
Yeah, the chip I'm using is 700 per piece, and there are two chips and two ESP32 modules. So yeah, it is costlier, but it's cheaper than the lifetime things like that.
I mean, the giveaway is nice. 100 kilometers is for 700 rupees. It's good.
Yeah, this is the ELRS repo. This is the open source project. You can just download it and use it. It's
So
free.
sorry to interrupt, but there is some noise coming from the mic. I cannot hear you clearly.
From my mic or someone else.
I think it is yours. I'm not sure though.
Mine. Let me see. I don't know. I can't see any noise behind me.
No, it's electronic disturbance. Not.
Maybe. Maybe.
Yeah, it's better now. It's better.
Oh, better. Yeah.
Yeah.
So what I was talking about, yeah, the ELRS thing.
Yes. Yeah.
This is the one I am using. If you want to build your own, you can go their hardware and DIY transmitter and receiver, and you can build these. These are open source. This is the chip that I'm using.
Mm.
If I can show you the chip also, the E28. This is the one. Yeah, this is the one I'm using with
Mm.
the ES32 module. And if you want, you can build it also.
Built like built the chip.
No, how can I show it? Just need to connect wires to the ES32 to the this module, and it will work. Simple.
Oh, okay.
Uh, but I don't really recommend you do this if you don't know what you're doing. But you can easily fry this chip. They are
Yeah.
very delicate components, if you ask me. So yeah, while we are in this topic, let me show you my drone also. It might give you some confidence about my skills.
I mean, I first need to have some confidence in my own skills.
Let me just show you the drone I'm working on. It's still work in progress. The
Mhm.
project never ends, if you know what I mean.
Yeah.
Yeah, this is the drone I have made. It's a
Oh,
6-inch drone.
the body looks 3D printed too.
Yeah, it's 3D printed.
You have a 3D printer.
Yeah, yeah.
Wow.
So this is the drone. You will not like this, but I will. The drone will make in CAD will be a much simpler one. This is too complicated. If you can see, this design is organic design. This,
Hmm. It is aerodynamic and it is lightweight.
yeah. So I will making a simple 5-inch drone in the class as to not complicate the matters further.
But are you planning on like competing in some competitions or tournaments with these?
And I don't really go into any competition thing. I just make things for fun. You know what I mean?
So this is just a very interesting hobby.
Yeah, it's just a hobby. That's all I can say. So let me
Okay.
also show you the components we will be using. Then if you can, yeah, this is the main computer we are using, microcontroller STM32 F411. This is
Mhm.
the MPU 6050 microcontroller. And this is a barometer, which basically tells the your drone's altitude. It's
Mhm.
required when you need a feature called altitude hold in your drone, which is basically a feature where a drone hold its position in the air.
Right.
Just height, not left right, just height.
Right.
Okay. Then we got this. This is a GPS module. The one I have is a Neo 6M. Other than that, I have, I think it's a magnetometer, basically a compass. You will need it with your GPS if you're gonna use a feature called RTS, means return to home.
Acha, so that then it saves the starting coordinates and then it returns on its own.
Yeah, if your um, link broken or something else happen, it just come back to the
Gotcha.
home position.
Oh wow.
And this is, if you can see it, I have a lighting problem, so please avoid it. I will try to fix it till next class, so we will get a better light. This is a flash chip. This is a 16 MB flash chip. It is used to store the flight data, also known as black box in quadcopter world. So it basically stores the data like your sensors data, so you can watch it after you land or crash. Basic mostly when you crash, see to see which sensor fail and how it fail.
Acha,
So
so it's mostly an error fixing thing.
yeah, it's for error fixing or you need some data.
Right.
Other than that, I think yeah, these are the basic components we will be using in this course, if you say so. Other than that, what other thing is there for the drone building? I think it's time. It's 8. I think we can wrap it up in 2 to 3 minutes. Anyone have any question?
Few months
No.
ago, I buy some mentalism toolkits from eBay. So there is one tool that very simple actually. When you press any button in there, it's look like a keychain. So when you press any button, the another device vibrate according to that. So
Uh,
can we make something simple to understand the fundamental things? Because I'm data science student and I don't have much idea about electrical things.
if you're looking for something simple, I think you can join the bot course, the robotic bot course. I- There you will learn from basics, the programming and electronic components and everything. This drone course is a little advanced, so yeah,
Oh, okay.
yeah. I think we got some questions. What are it is true that you are part of the electrical engineering batch, sir. Nah, I'm doing the ITM ES course standalone. I don't have any other degree going on. If I am not wrong, you are an ES student of BS. Yeah, I am a ES student. What are you currently doing? Please give some tips for absolute beginners. Tips in what field? I will ask. What is your ambition? I don't know what my ambitions are. I myself am finding my own ambition, if you say so.
Hello, sir.
Yeah.
Sir, what is the budget of to make a perfect drone?
What? Say it again.
Sir, what will a budget will be like that? How to make a perfect drone?
Perfect drone. See,
Mm.
the motor I am using, I won't recommend them to anyone. If you are seriously building something for like what God can I say, something rigid. I purchased this motor because I know I'm gonna burn them eventually. So yeah. So if you are gonna make something which is pretty what I say, pretty reliable and high end, then the cost of motor will be probably will be high because the good quality motors are 1,000 rupees per piece. So yeah. And if you are not building your DIY system, you can just go with what was EDBF 405. I think this stack. Yeah, like these are the pre-built flight controllers. If you are not wanna do a DIY kind of thing and make a high quality stuff, you can use something like this. This is a flight controller, and they also come a stack of ESC where the four ESCs are in like the board here is I can see, yeah, there. This is a flight controller, and beneath it it's a ESC. So you can use this if you're gonna make something reliable. But if you are gonna build something like I did, the budget will be around 3 to 4K. Hopefully I answered your question. If you have any other question, you can ask. If you have some doubt, you can ask.
No, no, thank you, sir. It is clear.
Yeah, because the motor I use are pretty cheap motor, if you say so. Because the price of motor which I get is 300 per motor, 300 per ESC, and the flight controller I made myself, which cost around 300 for board, and 100 if you use MPU 6050 microcontroller IMU, which costs around 100. So yeah, you can make it in pretty cheap if you want to do something. The most costly thing you will find will be the transmitter receiver and battery. Those are the most expensive things you will find. Any more questions?
Sir, from where you have learned this,
I'm doing it
if you
for
don't mind?
quite. I'm doing it for a quite while, so I even I don't know where it started and where it ended. I just keep on making something, and just keep on piling up and things like that.
Okay, so that's good.
You can always start. There's nothing like you can't start now or things like that. You can just start whenever you want. Start with basic projects and go from there.
So what kind of basic projects should we start?
You can start with a basic bot, I will say.
Like examples, please.
Any kind of bot. I What example can I give? Like a basic four motor, four wheel bot, like the one they are currently making in the bot course. If you are not enrolled in it, you can enroll in the bot course. There you will learn basic programming and sensors and everything. If you want to learn from the basics, you can join the bot course or also. Bot, I think it was. Might as well change this. Bot like bot like this. You can see here. If you want to learn from the basics, you can join this course. So this is the
Okay,
most
sir. Okay.
this is as basic as you can go. Nothing is more basic than this. Any other question?
No, sir. Thank you, sir, for clearing my doubts.
No problem. Oh, I think it's time to wrap this up. I think time. Also, I was showing these. Yeah. So this is also an open source flight controller for TNC microcontroller. If you want to check it out, you can also check this out. And this one is for Raspberry Pi Pico. So if you ever get chance, you can look into it and see.
So, sir, let's say I want to start making a drone, but I don't want to buy seven kinds of different boards and controllers. Is Raspberry Pi a good idea to start with?
I don't think that's a good idea because Raspberry Pi don't have I can say the real time response which required in the application like drones. Raspberry Pi is better for computing, not for the speed which you will need in things like drone and things.
Sure.
So if you want to use Raspberry Pi, use it with a combination of something like STM32 and something like that, which has the speed, and just you can run some heavy code on Raspberry Pi and let the microcontroller like STM32 and something like that control the flight controller.
Mhm.
It's not like you can't build it, but it's just not that good idea to use Raspberry Pi in drone.
Okay, okay. Thank you, sir.
Any other question? How many students did we get? Nine. I think pretty good. Uh, Jayavardhan, you were saying something?
No, no, sir. Nothing.
Anyone else? Any question?
No, sir.
Okay, I think we can wrap this up. It's 1 hour, 1 hour already. So yeah, the next class will be on what component to choose. If you say so, we will see what other options we have. If you don't want to go with this one, and we will flash the firmware, the pre-built firmware into the controller, calibrate it, configure it, and make it ready for the what can I say flight. So that will be our next task in the next class. So yeah, If anyone don't have any question, we can end this. Okay. Okay, guys.
This was a great session, sir. Thank you.
No problem.
Bye, sir. Thank you so much.
Okay, okay. Also, thank you for joining. Meet you in the next session. Bye.